Hello students, welcome you all on behalf of Resonance, myself SRN sir. आज 29th शिफ्ट 2 की पेपर हम देख रहे हैं, मेमोरी बेस्ड वाले पेपर. चलो देखते हैं फर्स्ट क्वेश्चन क्या मिला है. विच ऑफ द फॉलोइंग इज ए सल्फाइड वोर? ऑप्शंस कैलामाइन, सिडराइट, स्पैलराइट, मैलेकाइट. अब इसमें कैलामाइन जिंक कार्बोनेट, सिडराइट आयरन कार्बोनेट, sphalerite is zinc sulfide, malachite is copper carbonate. So, the sulfide ore is sphalerite only. Next question, give the decreasing order of spin only magnetic moment of the following. Here the given complex ions, this is from coordination and frequently asking question related to magnetic moments. So, the first one is given FeF63 minus, second COF63 minus, third COC2O4 thrice 3 minus. In this, iron is in +3 state, its electronic configuration is 3d5 and in presence of CFT, according to CFT we will write electronic configuration of iron as T2G111 EG11. क्यों? यहाँ fluorine is weak field ligand. So, configuration will be like this. Number of unpaired electrons are 5. So, magnetic moment will be root over n into n plus 2 bm root over 35 bm. And COF63 minus, in this cobalt is in +3 state, it has 3d6 configuration and in presence of weak field ligand, the configuration is T2G211 EG11. Here number of unpaired electrons 4. And magnetic moment is root over 24 bm. And cobalt in +3 state, but here C2O4 2 minus oxalate ion. So, oxalate ion for cobalt +3, oxalate ion can act as a strong field ligand. And so, in presence of strong field ligand, configuration is T2G222 EZ00. So, number of unpaired electrons will be 0. Because in the d orbital splitting, if oxalate is acting as a strong field ligand T2G and in EZ orbitals, first T2G is filled in presence of strong field ligand and after that only electrons enters into EZ set. So, here first electrons are filled in T2G, so there will be no unpaired electron and it has 0 magnetic moment. Now, the decreasing order, so A greater than B greater than C. Next, how many of the following oxides are acidic oxides? In this, N2O3 dinitrogen trioxide, NO2 nitrogen dioxide, Cl2O7, SO2, these 4 only acidic oxides. Non-metal oxides are acidic oxides. Metal oxides are basic oxides and neutral oxides, that is N2O, NO and CO also. If CO is given, then you can also opt that CO is also a neutral oxide. Next, the first ionization enthalpy difference of boron to aluminum is more than that of aluminum and gallium. And second statement, it is given that gallium has completely filled d orbitals which have low screening effect. If you see the first ionization enthalpies, boron has 801 kilojoule per mole and for aluminum it is 577. So, there is a huge difference. And if you come to aluminum to gallium, this difference is only 2 kilojoule per mole. So, it is very less. And the reason for this is gallium comes after zinc. That means, in the zinc you can observe the d orbital is completely filled and in gallium also the d orbital is completely filled. So, it is argon 3d10 4s2 4p1. So, d orbital is completely filled. So, because of the poor shielding effect of this d orbitals, the electron gain ionization enthalpy for this gallium is compensated by this nuclear charge and low screening effect you can observe. That is why here the given two statements, that is gallium has completely filled d orbitals, yes it is correct, which have low screening effect, this statement is also correct, and the statement 1 is also correct. So, both statements are correct. Next, it is from chemical bonding, as usual bond orders calculation, frequently asking question. Compare the bond order of the following species: O2 minus 2, NO and CO. And if you observe the configurations, it is having bond order, the bond order is 3 for CO, and for NO it is 2.5, and for O2 minus 2 it is 1. By writing the molecular orbital configuration, we can calculate bond order by using this formula half into NV minus NA. NV means number of bonding electrons, bonding molecular orbital electrons, and Na means it is number of anti-bonding electrons. So, this is the calculation. Now, the order can be CO greater than, NO greater than, O2 minus 2. And next one, this is from atomic structure, very easy question. If Bohr's radius of hydrogen atom in ground state is 0.6 angstrom, find out the Bohr's radius of helium plus ion in third orbit. And we know the radius of nth orbit is R0 into n square by z, and here for first orbit of hydrogen we are calculating this R0 is equal to 0.6 angstrom. Now, for helium plus third orbit radius will be equal to R0 into n square by z. Here R0 is 0.6 and n value is third orbit, so 3 square, and z value for helium plus is 2, and on calculation you are getting 2.7 angstrom. This is from surface chemistry and related to colloids properties. Here the column 1, it is dispersion medium moves in electric field towards electrodes, and this is called as electroosmosis. Next, solvent molecules pass through semi-permeable membrane towards solvent side. This is called as the reverse osmosis. If semi-permeable membrane से solvent molecules towards solvent side आ गया तो. Next, third option, movement of charged colloidal particles under the influence of applied electric potential towards oppositely charged electrodes is said to be the electrophoresis. Next, solvent molecules pass through semi-permeable membrane towards solution side, this is said to be the osmosis process. So, this you have to match these definitions with these words. Next, for a reaction A gives B, the value of rate constant is 1.4 into 10 power minus 4 liter मोल इनवर्स सेकेंड इनवर्स. हियर द रेट कांस्टेंट यूनिट से आप इसकी आर्डर बता सकते हैं. क्यों, कैसे? रेट इक्वल टू यू नो, रेट इक्वल टू के इंटू concentration power n for nth order. Now k equal to rate upon concentration power n. Rate units mole, liter inverse, second inverse, and concentration units mole per liter power n. And if you bring this one, it will be mole power 1 minus n, liter power n minus 1, second inverse. And here liter power is 1, mole power is minus 1, second inverse. If you compare this, 1 n value will be equal to 2. N value will be equal to 2. That means order of the reaction is 2. If you compare these with the given units, then you will get n value 2. So, that represents order of the reaction. Next one, an organic compound of mass 0.1 gram on complete combustion with excess of oxygen gives 0.183 grams of CO2 and 0.181 grams of H2O. The percentage of carbon present in the organic compound is. Here mass of carbon present in 44 grams of CO2 equal to 12 gram. Mass of carbon present in 0.183 grams of CO2 will be 0.05 gram. Now percentage of carbon will be equal to 50%. This is from hydrogen. Nickel is used as catalyst in syngas production and edible fats. Yes, it is correct. The process of producing syngas from coal is called coal gasification. Yes, this is also correct. Both statements are correct. Here, nickel is used as a catalyst in the production of syngas, and hydrogenation of vegetable oils using nickel catalyst gives edible fats. And this is called coal gasification reaction. From carbon, you are getting CO plus H2, that is syngas. Next, this is also from hydrogen and its compounds. The statement 1, it is silicon forms both electron deficient and electron rich hydrides. It is incorrect. And all elements of group 14 hydrides are electron precise compounds and are in tetrahedral geometry. Yes, it is correct. So, statement 1 is correct, statement 1 is incorrect, statement 2 is correct. This is from thermodynamics, direct question, only formulas are given, you have to select which formula is correct. Here it is given delta G equal to delta H minus T delta S, it is at constant temperature and pressure. So, this is the correct relation. Next, for the calculation of entropy change, it is given as Q reversible by T, it is also a correct. And enthalpy change equal to Q plus W, first law, it is also correct. And delta H equal to delta U plus delta Ng RT, it is also correct. So, all the given statements are correct. Which of the following product is formed by the heat decomposition of lithium nitrate? So, कौन से products बनेगा? इसमें lithium nitrate especially on heating, it will give lithium oxide, nitrogen dioxide and oxygen. But other alkali metal nitrates on decomposition, they will give nitrites and oxygen. So, it is the anomalous property of the lithium. So, abnormal properties of lithium may you can observe this relation. Next question, this is from ionic equilibrium. The indicator used in the titration of X against sodium thiosulfate is Y. X and Y respectively are. इसमें आयोडीन सोडियम थायोसल्फेट से रिएक्ट हो गया तो सोडियम आयोडाइड एंड सोडियम टेट्रा थायोसल्फेट बनेगा और यहाँ ये इंडिकेटर को हम स्टार्च यूज करेंगे एंड द कन्वर्शन ऑफ कलरलेस सॉल्यूशन टू ब्लू इज द एंड पॉइंट. Now, this is the question from solid state. The all voids present in 0.02 mole of a compound forming hexagonal close packing crystal structure are x into 10 power 21. The value of x is. इसमें given compound का moles है 0.02. इसमें number of atoms हम calculate कर रहे हैं Na value से multiply करके. हमको Na वैल्यू दिया है 6 into 10 power 23, then it will be 12 into 10 power 21. Now, number of octahedral voids will be equal to number of atoms, so it will be 12 into 10 power 21. Now, number of tetrahedral voids will be equal to double the number of atoms, so 2 into 12 into 10 power 21, that equal to 24 into 10 power 21. Now, total number of voids will be equal to number of octahedral voids plus number of tetrahedral voids, that will be equal to 12 into 10 power 21 plus 24 into 10 power 21, that will be equal to 36 into 10 power 21. It is compared with x into 10 power 21. Now, it will be x value is equal to 36. This is from solution and colligative properties. You have to match the given column 1 and column 2. Van 't Hoff's factor can be calculated by this formula, normal molar mass upon abnormal molar mass. And isotonic solutions matlab solutions which are having same osmotic pressure are said to be the isotonic solutions having same osmotic pressure. Next, azeotropic mixtures. So, azeotropic mixtures means the mixtures having same composition in liquid and vapor phase and boil at constant temperature. These are said to be the azeotropic solutions. And Kf, it is nothing but cryoscopic constant. It is known as cryoscopic constant. So, we have to match like this, that is Van 't Hoff's factor can be S and isotonic solutions is P, azeotropic mixtures is Q and Kf is cryoscopic constant. This is a question from kinetics. A and B are radioactive atoms with molar mass 16 and 32 respectively. The half lives of A and B are 1 day and half day respectively. If initially 320 grams of each of A and B is taken, the total number of atoms left after 2 days are x into 10 power 23. The value of x is. इसमें number of moles of A, यहाँ तो A and B दोनों 320 grams दिया है, तो moles हम calculate कर रहे हैं 20 moles and 10 moles because the molar mass is given 16 and 32. Now, after 1 day, it will become half because half life is 1 day, 20 moles will become 10 moles and after another day, it will become 5 moles. That means, after 2 days, you are getting 5 moles of A. And same thing, B is also initially 10 moles. After 2 days, you are getting 0.625 moles. Now, the number of A atoms left after 2 days is 5 into Na and it is 30 into 10 power 23 atoms. Number of B atoms left after 2 days is 0.625 into Na, that is 3.75 into 10 power 23 atoms. Total number of atoms left after 2 days will be around 33.75. If you round off, it will be 34 into 10 power 23. So, x value can be 34. We have to represent the nearest integer. Next question, this is from mole. 0.69 gram of sodium reacts with water and produces sodium hydroxide, which is neutralized by 73 gram per milliliters of HCl. The volume of HCl required for complete neutralization of NaOH is x into 10 power minus 3 milliliter. The value of x is. Here, sodium on reaction with water produces hydrogen and sodium hydroxide. Number of moles of sodium will be equal to number of moles of sodium hydroxide. Here, number of moles of sodium hydroxide it can be calculated based on the mass of sodium. So, number of moles of sodium hydroxide equal to 0.03. Now, this sodium hydroxide is reacting with HCl and producing sodium chloride and H2O. Now, here also number of moles of sodium chloride, sodium hydroxide and HCl are equal. From this, I am equating molarity into volume of HCl equal to number of moles of NaOH. Here, we have to calculate this one, that is, it is given that 73 gram per milliliter. So, it is 73 by 36.5 into 1000 by 1. Now, this on solving, you will get V equal to 15 into 10 power minus 3 milliliter. That means, x value will be equal to 15. Next question, this is also from mole. A hydrocarbon for combustion requires 9.5 equivalents of oxygen and produces 3 equivalents of water. The formula of hydrocarbon is, इसमें hydrocarbon CXHY plus x plus y by 4 O2 gives x CO2 plus y by 2 H2O. Here number of equivalents of O2 will be equal to number of equivalents of H2O. Now, number of equivalents of H2O is given as 3. So, y value equal to 6 and number of equivalents of oxygen is x plus y by 4 equal to 9.5. If you put the y value here, you will get x value as 8. So, CXHY will be C8H6. Okay, students, that is it and we will meet again in the next class.